This video will demonstrate the head to tail or triangle method of adding vectors. Here we have our diagram with our sailboat, which is heading due south at 24 kilometers per hour, and this time the wind is blowing at 7 kilometers per hour in the southwest direction. So the angle between west and the wind here is 45 degrees, or between south and the wind is 45 degrees. The head to tail or triangle method of adding vectors requires you to take the vector that's being added and place its tail at the head of the other vector. So you want to physically redraw one of the vectors so that its tail is extending from the head of the other vector. So I've taken the vector that represents the wind's velocity and shifted it and placed it at the head of the vector that represents the sailboat velocity. The resultant is the vector that connects the tail of the first vector to the head of the second vector. So in this case, it is this vector. This is the resultant, which makes some sense. Imagine that the sailboat is set this course going straight south. The wind is pushing it slightly off course toward the southwest, and so it is slightly off the south. Now, to determine the magnitude and the direction of the resultant, we need to make sure we add some of our given information. So now I have added the magnitude of the sailboat vector, which was 24 kilometers per hour, and the magnitude of the wind vector, which is 7 kilometers per hour. So in this resulting triangle that was created by our two vectors, the sailboat and the wind, and the resultant of those two vectors, we now know these two sides. What else can we determine? Well, we knew that the wind was blowing in the southwest direction. So we know that this angle right here, notice that I've drawn in two perpendicular lines to represent the north, south, east, and west directions. So we know that this angle in our diagram is 45 degrees. So that's a 45-degree angle since the wind is blowing in a southwest direction. So that means that this angle in our triangle must be the supplement of 45 degrees. A supplementary angle makes a 180-degree sum with another angle. So this angle must be 180 minus the 45 degrees here. So this angle will be 135 degrees. So now we have two sides and the contained angle. We are interested in determining this vector, which I have marked V. We can use the cosine law, since we have two sides and the contained angle, to determine the magnitude of the resulting vector, and then we can determine this angle using the sine law to determine the direction of the sailboat.